Hey everyone, MKBHD here. Today, we're diving into the fascinating world of drones. These aren't just cool gadgets, they're complex machines with intricate architectures. Understanding how they work can be daunting, but we'll break it down together. We'll explore everything from the physical parts to the software that makes them fly. Whether you're a complete newbie or just curious about the tech behind these aerial wonders, stick around. It's going to be an exciting ride. Get ready to unlock the secrets of drone technology. We'll cover everything you need to know to appreciate these incredible machines. Let's get started. Every drone, no matter how big or small, relies on a combination of hardware components working together. Think of it like this. The hardware is the body, providing structure and power. First up, we have the frame, the skeleton of the drone. This can be made from various materials like plastic or carbon fiber, each affecting its durability and weight. Attached to the frame are the motors, the muscles of our drone, responsible for generating thrust and spinning the propellers. Then we have the ESCs, or electronic speed controllers. They act as the nervous system, regulating the power delivered to each motor, allowing for precise control over the drone's movements. Finally, we have the battery, the heart of the drone, supplying the energy needed for all these components to function. Now let's talk about the brains of the operation, the software and communication systems. This is where things get really interesting. At the heart of it all is the flight controller, a tiny computer that processes sensor data and translates your commands into actual flight. This little chip handles everything from stabilizing the drone to navigating waypoints. It's also responsible for communicating with you, the pilot, through a radio link. This link uses specific frequencies like 2.4 GHz or 5.8 GHz to send and receive control signals. But it's not just about control, it's also about data. Modern drones use protocols like Mavlink to transmit telemetry data back to you, providing real-time information about altitude, battery life, and GPS coordinates. Understanding these software and communication aspects is crucial to truly mastering drone flight. Now that we've covered the individual components, let's see how they come together in different drone architectures. The most common design you'll encounter is the quadcopter, with its 4 rotors providing excellent stability and maneuverability. But drones come in all shapes and sizes. You have hexacopters with 6 rotors, octocopters with 8, and even more exotic designs like tricopters and fixed-wing drones. Each architecture has its own advantages and disadvantages in terms of stability, payload capacity, and flight time. For instance, more rotors generally mean more lifting power, allowing for heavier payloads like professional cameras. However, they also consume more battery, affecting flight time. Understanding these trade-offs can help you choose the right drone for your specific needs and applications. Section 5. Decoding the components, a guide for beginners. Now, identifying specific drone components might seem daunting at first, but it's easier than you think. With a bit of practice and understanding, you'll be able to recognize each part and its function effortlessly. Let's start with the motors. These are the heart of your drone, providing the necessary power to lift and maneuver. You'll often see a kV rating on them. This rating is crucial for understanding the motor's performance. This indicates how fast the motor spins per volt applied. For instance, a motor with a kV rating of 1000 will spin at 1000 revolutions per minute per volt. A higher kV means more speed, while a lower kV generally translates to more torque, suitable for lifting heavier payloads. This is particularly important when considering the type of drone you want to build or fly. Next, look at the propellers. These are just as important as the motors and come in various sizes and pitches. The size and pitch of a propeller can significantly affect the drone's performance and efficiency. Pitch refers to the angle of the blades. A higher pitch means the blades are angled more steeply. A steeper pitch generates more thrust but also consumes more power. This trade-off is something to consider when choosing propellers for your drone. Understanding these basic parameters can give you a good idea of a drone's capabilities. Finally, let's talk about the flight controller. Entry-level drones might have basic flight controllers with limited features. These are great for beginners who are just getting started. As you move towards more advanced models, you'll find flight controllers with integrated GPS, barometers, and even advanced sensors for obstacle avoidance. These features can greatly enhance your flying experience and provide more stability and control. Knowing what to look for can make a world of difference when choosing the right drone. Whether you're a beginner or looking to upgrade, understanding these components will help you make an informed decision. Section 6. Taking control, choosing the right controller. Now, let's talk about how you actually control these flying machines. The controller is your primary interface with the drone, and choosing the right one can make a significant difference in your flying experience. The most common way is using a dedicated radio transmitter, often referred to as a remote controller. These devices are specifically designed to communicate with your drone, providing reliable and precise control. These come in various shapes and sizes, each designed for a specific level of control and functionality. From compact, portable models to larger, more complex units, there's a controller for every type of pilot. Basic controllers might only have a few sticks and buttons, allowing for basic movements like throttle, yaw, pitch, and roll. These are perfect for beginners who are just getting started with drone flying. More advanced controllers offer a plethora of switches, knobs, and even customizable buttons, giving you granular control over every aspect of the drone's flight. These are ideal for experienced pilots who need precise control for complex maneuvers, but it doesn't stop there. The world of drone controllers is constantly evolving, with new technologies and features being introduced regularly. Some drones can even be controlled using your smartphone or tablet via dedicated apps. These apps often provide a more intuitive interface, especially for beginners with on-screen joysticks and easy-to-access settings. These apps can also offer additional features like flight planning, real-time telemetry, and even automated flight modes, making it easier than ever to fly your drone. The choice is yours, depending on your comfort level and the level of control you desire. Whether you prefer a traditional remote controller or the convenience of a smartphone app, there's a perfect option out there for you. Take your time to explore and find the one that best suits your needs. Section 7. From parts to flight, assembling your drone. Now, for those who like to get their hands dirty, building a drone from scratch can be an incredibly rewarding experience. Don't worry, it's not as complicated as it sounds. Many drone kits available today come with detailed instructions and all the necessary components. The assembly process usually involves mounting the motors to the frame, connecting the ESCs, attaching the propellers, and securing the flight controller and other electronics. It's like putting together a high-tech puzzle. Once assembled, you'll need to install the drone's firmware, which is essentially its operating system. This might sound intimidating, but it's usually as simple as connecting the drone to your computer and following the on-screen prompts, and just like that, you'll have a drone ready to take to the skies. Section 8, ready for takeoff, basic flight maneuvers. In this chapter, we will guide you through the essential steps to get your drone airborne and flying smoothly. So, you've got your drone ready to go. It's fully charged, calibrated, and ready for its first flight. Now the real fun begins. Learning to fly. This is where you start to see the world from a whole new perspective. The first step is understanding the basic flight controls. These controls are your primary tools for navigating the skies. Most drones use a combination of throttle, yaw, pitch, and roll to maneuver through the air. Each control has a specific function that helps you direct the drone's movement. Throttle controls the drone's altitude, allowing it to ascend and descend. Yaw controls its rotation, helping you change the direction the drone is facing. Pitch controls its forward and backward movement, enabling you to move the drone in a straight line. And roll controls its side-to-side movement, which is essential for making smooth lateral adjustments. It might seem overwhelming at first, especially with so many controls to manage simultaneously, but with a little practice, these movements will become second nature. You'll soon find yourself flying with confidence and ease. Start by practicing in a safe, open area away from obstacles and people. This will give you the space you need to make mistakes and learn from them without any risk. Begin with simple maneuvers like hovering, gentle ascents and descents, and gradual turns. These basic moves will help you get a feel for the controls. As you gain confidence, you can move on to more advanced maneuvers like flying in different directions, performing controlled landings, and even executing more complex flight patterns. and even learning basic aerial photography techniques. Capturing stunning aerial shots can be one of the most rewarding aspects of flying a drone, adding a new dimension to your piloting skills. Section 9. Exploring the skies responsibly. As we conclude our deep dive into drone technology, it's crucial to remember that with great power comes great responsibility. Flying a drone is not just about having fun, it's about being a responsible pilot and respecting the skies we share. Always familiarize yourself with local regulations and airspace restrictions before flying. Obtain any necessary permits or licenses and prioritize safety at all times. Respect the privacy of others and avoid flying over private property or crowded areas without permission. Remember, drone technology is constantly evolving, offering endless possibilities for exploration, creativity, and even professional applications. So keep exploring, keep learning, and most importantly, keep flying responsibly.